May 28, 1940. Reich Air Ministry, Berlin. Hermann Göring, Marshal of the Luftwaffe, holds in his hands a report just brought by his intelligence officers. In it, an absurd promise. President Franklin D. Roosevelt had asked Congress for authorization to begin production of 50,000 military aircraft per year. Göring didn't hesitate. He laughed. To him it was American propaganda, the delirium of a people who knew how to assemble cars but would never understand the refined art of military aviation. The American thesis, judged by the Germans as folkloric, hid a silent industrial plan. In the warehouses of Detroit, William Knudsen, a former General Motors executive, was already beginning to coordinate what would become the largest factory transformation in human history. It wasn't just about airplanes, but about pace, scale, standardization, logistics, and operational redundancy, words Göring never took to heart. This video is the chronicle of a technical humiliation, of how Nazi arrogance confronted the real power of a mobilized democracy, and how America not only met Roosevelt's goal, but doubled it, crushing the Reich under 100,000 aircraft. Göring's laughter was the most costly sound of the war. But before we dive into the reports, there's one statistic that defines this whole story. In 1944, a single American factory, Willow Run, in rural Michigan, produced 428 bombers in just 30 days. In that same period, the entire German airline industry could barely match that figure in a full month of military effort. By the end of the war, the United States would deliver nearly 300,000 military aircraft. Germany, a third of that. The difference was not only in machines but in mentality. What the Reich saw as industrial arrogance was actually a new kind of warfare, fought with riveting machines, spreadsheets, and discipline. And it all started with a simple miscalculation. If you value the story told accurately and want to continue seeing the past being reconstructed with facts and irony, leave the like and subscribe. This helps the channel keep alive the memory of what arrogance once dared to underestimate. May 1940. As German tanks tear through France like a blade slicing through paper, President Franklin Delano Roosevelt stands before the U.S. Congress with a request that many would call insane. He does not speak of battalions nor of squadrons, but of a number that would change the war. Roosevelt wants the country to produce 50,000 planes a year. At that time, the United States can barely manufacture 3,611 military aircraft annually. The arsenals are rusty, the air doctrine is timid, and the American generals themselves frown. For many, it is yet another inflammatory speech, a rhetorical response to a collapsing Europe. But Roosevelt is not improvising. Days earlier, he had called to the White House a man with no military rank but a history of industrial warfare. William S. Knudsen, former chairman of General Motors, architect of the modern automotive assembly line. Roosevelt offers him an informal position to lead the mobilization of American industry. Wage, $1 a year. Mission, make the impossible routine. On the other side of the Atlantic, the Reich hears the announcement and laughs. Luftwaffe intelligence records the American intent as a symbolic threat. Göring disdains. Let them try to turn car workshops into war factories. Building a car is not the same as making an airplane. In Germany, the concept of mass production applied to aviation is viewed with skepticism. Air warfare, for Reich strategists, is still considered a craft precision art, not a product of industrial drawing boards. The irony sets in right there. While Germany sees the war as an elite technical opera, the United States is preparing a large-scale mechanical symphony. Knudsen then springs into action with the precision of an engineer and the speed of a shop floor manager. He calls on civilian manufacturers such as Ford, Chrysler, Douglas, Lockheed, Boeing, and North American. Meetings are scheduled, plans are sketched, assembly lines are redesigned. The American industrial sector, until then focused on refrigerators, radios, and automobiles, is beginning to breathe aluminum, rivets, and turbines. Knudsen doesn't care about the skeptics. He talks about patterns, interchangeable parts, modular production. While German engineers discuss aerodynamics in closed rooms, the Americans begin training welders in record time. The initial response of the German high command is one of superiority. They can produce more, but never with the quality of our engineering, General Feldmarschall Erhard Milch would say. But what they called excess production would soon turn out to be sustained capacity. With each passing month, the United States doubles its goals. In 1941, still not officially at war, The country already produces almost 20,000 aircraft, and that's just the beginning. The reality that Nazi intelligence ignores, or prefers not to report, is that the American industrial system not only multiplies quantities, but accelerates innovations. While the Luftwaffe tries to keep production lines decentralized and secret, the Americans are betting on standardization. Airplanes such as the B-17, B-24, P-38, and P-51 are manufactured in series, with interchangeable parts produced in different states and assembled as mechanical blocks in synchronized rhythm. A statistic from late 1943, often ignored by German analysts, is revealing. The United States produced more than 7,000 airplane engines a month that year, 10 times more than Germany's monthly capacity. If this data surprised you, write in the comments, "Logistics wins," because this is the blind spot that arrogance does not see. Quantity, quality, and continuity can indeed go together. The American Congress, previously reticent, is beginning to notice the movement. War bonds are issued, taxes reconfigured, subsidies released. The aviation industry in just 3 years becomes the largest on the planet. But none of this occurs by miracle. What is underway is a new kind of war, a war of engineering, of supply chain, of systems. Knudsen and his team don't just transform factories, they rewrite the logic of time. Where it used to take weeks to assemble a fuselage, progress is now measured in minutes. Meanwhile, German reports continue to mock. As late as 1942, an internal Luftwaffe document states, "The entry of women into American factories shows the growing desperation of the enemy." What they called desperation proved to be adaptation. What they saw as weakness turned out to be collective strength. Roosevelt, for his part, does not back down. On the contrary, he puts even more pressure. In 1942, already in the heat of war, he announced an even more aggressive goal: 125,000 planes. It is a statement of intent, but also a strategic move. He knows that the war will not be won in trenches. It will be won in riveting machines, turbines, cranes, and rails. The clash between contempt and technical planning is formed. On the one hand, an empire that believes in the superiority of race, aesthetics, and tradition. On the other, an industrially literate, pragmatic, and efficiency-obsessed democracy. The Luftwaffe still reigns supreme in the skies over Europe, but a silent shadow is already beginning to form on the horizon. The distant sound of a Wright cyclone engine being fired up every hour. But the real turning point was yet to come. Because Knudsen wasn't alone. In Michigan, Henry Ford was preparing something that would perplex Germany itself. A factory where one bomber would leave per hour. Her name? Willow Run. And when Göring knew that, he would stop laughing. But it would be too late. To the Third Reich's high command, the United States was not a real military threat. It was a moral caricature. Adolf Hitler saw America as a racially degenerate, culturally disorganized, and spiritually weakened nation. Half Judaized, half blackened, the Führer once said, incapable of sustaining a long war. This assessment came not only from prejudice, but from a mental structure that confused order with rigidity and confused democracy with weakness. Hermann Göring, at the head of the Luftwaffe, did not hide his contempt. For him, Americans could make cheap cars and consumer radios, but they would never understand the sophistication of air warfare. Producing a fighter was not like riding a Ford. War required precision, not quantity, and this, in the Germanic view, was exclusive to Aryan engineering. But while the Nazis were confident in their own innate superiority, reports from Washington were beginning to paint another picture. The German military attaché Friedrich von Boeticker, based in the United States since 1933, sent a series of detailed documents warning of the American factory movement. His analyses were not alarmist. They were statistics. In 1940, Boeticker wrote that American war production, if fully mobilized, would reach levels inconceivable by European standards. Berlin read, archived, and discarded it. The messages were seen as defeatist, contaminated by the liberal environment. And so the Reich remained blind. The Luftwaffe, while effective in the early years of the war, remained a force designed for blitzkrieg, rapid attacks, focused on ground support and regional dominance. It had not been designed for a prolonged war of air attrition, much less against an enemy that manufactured aircraft on an industrial scale. Still, the conviction was solid. The war would be won by excellence, not by the masses. The idea that thousands of workers without military training, coordinated by civilians and civil engineers, could mass-produce bombers was laughable to the Reich. Even more laughable was the fact that women, and worse, women from minorities, entered American factories. An Abwehr report, dated December 1941, described this as a clear sign of organizational decay. For Luftwaffe officers, the entry of women into the production lines indicated imminent collapse. The analysis ignored a critical factor. In the United States, democracy had learned to mobilize talent, not to discard it. Nazi ideology precluded any realistic reading of the adversary. While Goebbels organized propaganda parades extolling racial purity as the engine of victory, Americans recruited Jewish mathematicians, exiled German chemists, black factory workers from the rural South, children of Italians from Brooklyn, and teenagers from Iowa. The American workforce was chaotic in the eyes of the Reich, but it was this chaos, creative, adaptable, technical, that would transform the war. German blindness was systemic. In the rigid structure of totalitarian command, there was no room for flexibility or quick response to contradictory data. Once the narrative of German industrial superiority was established, it became dogma. Reports that contradicted it were considered treason. An internal memo from 1942 shows that Luftwaffe officials even rewrote figures on American production to make them more plausible. The truth was too inconvenient. Göring, the central figure of the miscalculation, continued to feed the illusion. In 1941, he declared to a group of officers, "Even if the Americans enter the war, it will take years before they understand how to fight. We will already be in Moscow." He believed that the war would be won before the first American plane crossed the Atlantic. There was no contingency plan to face 100,000 enemy aircraft, because no one believed it was possible. This refusal to accept American industrial potential had practical consequences. While Germany invested in industrial dispersion programs, such as Jägerstab, and in underground factories that used slave labor under unsanitary conditions, the United States invested in standardization, logistics, and replacement capacity. The Germans built planes in parts in distant locations with lines interrupted by bombing and internal sabotage. The Americans, on the other hand, built entire factories around the idea of continuity. Germany was trying to protect what it could no longer sustain. America was expanding what the enemy did not believe could exist. Ultimately, Reich's mistake was not only to underestimate American production, it was underestimating the capacity of a democracy to organize itself under pressure. Ideological prejudice blocked rational analysis. When Göring mocked Roosevelt, he didn't just laugh at a plan. He laughed at the very idea that a democratic system could win a technical war. He laughed at the possibility of a factory run by civilians overcoming a militarized state. He laughed at a force that did not wear a uniform, but that knew how to assemble planes at the rhythm of a clock. But time, this invisible clock, was ticking. In December 1942, a Luftwaffe general, after visiting damaged production lines, whispered to a colleague, "If they really manage to make 50,000 airplanes, we will have no more skies." The colleague replied, "They won't make it." 2 months later, the Americans were already exceeding 4,000 aircraft per month, and in the industrial heartland of America, a promise was approaching the flashpoint. In Michigan, an assembly line stretching for more than a mile was about to put the most produced bomber in history into the air. It was the answer not to Göring's laughter, but to the logic of his mistake. The next installment will reveal how a factory built on agricultural land became the symbol of an impossible turnaround and the Luftwaffe's nightmare. In 1940, as Germany rejoiced at the fall of France and the Luftwaffe consolidated its supremacy in the skies of Europe, one man quietly began to turn the tide of the war, without wearing a uniform, without speaking in squares, without promising victories. William S. Knudsen was a Danish immigrant who had climbed the ranks of the American auto industry with an almost surgical instinct for large-scale production. President of General Motors, responsible for integrating thousands of parts into standardized systems, Knudsen was not a military strategist, but he understood something that the Reich leadership ignored. The real power was not in rhetoric, but in repetition, and in the ability to transform complexity into a continuous flow of assembly. Rather than remain at the corporate top, Knudsen accepted Roosevelt's invitation to lead the American industrial conversion with a token salary of $1 a year. He didn't enter the war for money, he entered for method. His first decision was the simplest and the most radical. Knudsen would not try to force the traditional arms industry to expand. Instead, it would bring the civilian sector into the war. Engineers who had previously designed coupes now designed fuselages. Mechanics trained in transmissions now assembled aviation engines. He knew that airplanes are not works of art, they are products, and products can be standardized. This view, that a bomber could be built like an automobile, seemed absurd to the eyes of traditional engineering, especially those of the German elite. But Knudsen was about to prove that repeating accurately was more lethal than innovating exclusively. Under his coordination, factories of Ford, Chrysler, and other giants of the automotive sector were converted in record time. It was not enough to build aircraft. It was necessary to build them en masse, with interchangeable parts, at a continuous pace, and with logistical flexibility. Ford, for example, which used to produce a car every minute, would be challenged to apply the same principle to aviation. To this end, Knudsen established partnerships between competing companies, standardized measurements and materials, distributed contracts strategically. Instead of centralizing, he decentralizes with method. The secret lay in what he called horizontal flow. An airplane began to be assembled in one state, received parts in another, and was finished in a third. Each factory produced sub-assemblies, wings, tails, engines, electrical systems, that reached the endpoint with millimeter precision. The concept was the opposite of German logic, which saw each plane as an individual handmade project. For Knudsen, this romantic view of aviation belonged to the past. He didn't want to build 50,000 airplanes. He wanted to build a machine that could build them, and that machine could work without interruption. Behind the scenes, he was described as methodical, tireless, and above all, silent. There was no grandiloquence in his posture. While Göring ranted about the domain of the heavens, Knudsen drew production flowcharts. In 1941, when the first contracts began to deliver results, he insisted on personally visiting the factories, listening to the workers, adjusting lines, shortening deadlines. When a plant in Buffalo was delaying deliveries because of a lack of aluminum, Knudsen redesigned the supply in the early hours of the morning. Where the Reich saw glory and destiny, he saw bottlenecks and spreadsheets. The turning point came with the fusion between planning and execution. In just 2 years, American production jumped from just over 3,000 aircraft to almost 50,000. The Germans, even with their system of forced production, have not been able to surpass the barrier of 30,000 in any year. Knudsen didn't just exceed the targets, he anticipated shortages, organized the supply chain, and built an invisible civilian army. Each worker trained by his programs multiplied the factory capacity. Each patterned piece was a victory over entropy. The irony did not go unnoticed by some observers. A German general, after being captured, declared in 1945, "We do not lose to tanks but to schedules. We don't lose to generals but to managers." The phrase, recorded in interrogation, summarizes the Reich's error of perception. They had prepared war against soldiers, but they faced engineers. Knudsen was also responsible for driving the use of statistics as a weapon of war, implemented quality control systems with probabilistic sampling, anticipated production failures with data, and created cross-inspection programs between factories. These innovations would later be the basis for what we now call modern industrial management. At the time, they were simply instruments of survival. But perhaps Knudsen's greatest legacy was proving that democracy was compatible with efficiency, that a country where workers could come and go, where unions had a voice, where companies competed for the market, could still unite under a common goal and meet almost mythological goals, not out of fear, but out of purpose. In 1943, Knudsen left his position at the War Production Office, having already laid the foundations of a war machine that operated with the precision of a clock and the scale of an avalanche. He would return to private enterprise as a man who, without ever stepping on a battlefield, had won one of the most decisive wars in history, the war against time, against miscalculation, against arrogance. But while the numbers grew in the United States, an even more ambitious project took shape on the outskirts of Detroit, a factory that promised not only to produce bombers, but to produce them as if they were automobiles, one every 60 minutes. Her name was Willow Run, and she was about to redefine the concept of the impossible. In 1941, as Germany buried its assembly lines deeper and deeper under the earth to escape Allied bombing, the United States was building, in the agricultural heart of Michigan, the largest factory the world had ever seen. It was called Willow Run. There, on a plot of land that once housed crops, the Ford Motor Company promised something bordering on technical insanity, churning out one B-24 Liberator bomber per hour. The plant would occupy more than 3.5 million square feet and feature a continuous assembly line that would span more than a mile. Henry Ford, patriarch of mass production, envisioned applying to the war effort the same principle that had made the Model T a popular icon, mechanical repetition as a tool of scale. But turning this vision into reality would be an arduous, tortuous, and for a time, humiliating path. The beginning of Willow Run was a disaster. The first bomber assembled there had to be dismantled and rebuilt almost from scratch. Quality control was inconsistent. The pieces did not fit together precisely. Coordination between suppliers failed in a cascade. The schedules were not met. The press did not forgive. The plant was nicknamed Will It Run, a cruel irony to the expectation of continued production. The Army Command itself even questioned whether the project was too ambitious, too technical, too American. But the initial failure was the foundation of a turnaround. Unlike Germany, which faced delays and sabotage in its underground factories, the United States could make mistakes and learn from the mistake. The answer was technical, not ideological. Engineers divided the B-24 into 488 standardized subassemblies. They created specific hydraulic tools for each type of rivet. They implemented the use of pre-assembled wiring harnesses and mobile crane systems for the internal transport of heavy parts. The workflow started to operate in 3 uninterrupted shifts. A new track system guided the bombers through the plant as if they were giant automobiles. Each station had metrics, goals, and efficiency tables. Production was measured in minutes, not days, and each month the numbers went up. The irony of this story is that the solution was in front of them all along. It was enough to apply with absolute rigor the principles of civilian industry to the military effort. If you are enjoying unraveling how these historical gears connect with millimeter precision, show your support, like and subscribe so that we can continue to bring you content with this level of technical and human detail. Willow Run has evolved. From 56 monthly bombers in early 1943, production jumped to 148 in September of the same year. In December, it reached 365. And at its peak in April 1944, it produced 428 bombers, one every 63 minutes. Each aircraft carried 5 tons of bombs, 10 50-caliber machine guns, and was built by a workforce composed mostly of civilians with no previous aviation experience. There, factory workers, housewives, retired mechanics, and young college graduates turned aluminum, steel, and oil into war machines that would cross the Atlantic to bomb the cities that once mocked them. On the German side, the reports were beginning to arrive with a tone that the censors could no longer conceal. Luftwaffe intelligence did not understand how a democracy could operate at an all-out war pace without resorting to coercion. How was it possible to maintain 3 shifts, 6 days a week, without the use of forced labor? How did the quality not drop, even with so many inexperienced hands? What the Germans called chaotic production turned out to be, in practice, a synchronized gear with flexibility. Willow Run was no exception. It was the rule of a new war. With each bomber that left the assembly line, an equation was solved against the Reich. Speed plus standardization plus logistics, air superiority. And even though the practical results were just beginning to manifest themselves in the skies of Europe, behind the scenes of the Reich, the unrest was already visible. In February 1944, Göring was informed that a single American plant alone exceeded the entire productive capacity of the Luftwaffe in that quarter. His silence in the face of the data was interpreted by his closest officers not as surprise, but as internal surrender. But the full impact of this factory was yet to come, because Willow Run didn't just produce airplanes, it shortened the war. The next installment will reveal how quiet mobilization inside the assembly line turned into coordinated destruction in the skies over Germany, and how an army of uniformed civilians inflicted a mathematical defeat on Luftwaffe pride. When the first German intelligence reports indicated that American factories were being occupied by women, the reaction in Berlin was one of derision. For the Nazi leadership, this was an unmistakable sign of decadence. In the mentality of the German war machine, dominated by a rigid and patriarchal ideology, the image of female civilians operating industrial tools was seen as a desperate gesture by an unprepared nation. An internal Luftwaffe report, issued in 1942, recorded, "The enemy's female mobilization demonstrates imminent logistical collapse. American aviation, if it depends on female workers, will not maintain a combat standard." The error of judgment was absolute. American women didn't just fill in the spaces left by enlisted men, they refined production, increased quality, and revolutionized the process. At Willow Run, for example, 65% of the workforce was made up of women. It was no exception, it was standard. Rosie the Riveter, symbol of the American riveter, was not an advertising invention. It was the reality of entire factories. Women like Roseville Monroe drove 3,000 rivets per shift, with 99.5% accuracy. Others operated hydraulic presses, welded structures, tested electrical components, and calibrated flight instruments with a level of attention to detail that dramatically reduced line failures. In Long Beach, the Douglas aircraft plant revealed a drop in defects from 3.2% to 0.3% after replacing male operators with women at inspection stations. What for the Germans was a sign of weakness, in the United States became a competitive advantage. Engineers quickly noticed that smaller hands were better suited to the inner spaces of the fuselages. The tools were redesigned to allow for thinner grips and lower range movements. The result was more comfort, less fatigue, and higher productivity. Light pneumatics replaced the heavier equipment. Adjustable desks were installed at a rapid pace. Ergonomics, ignored by German factories, became an ally of American workers. And the impact was not only technical, it was moral. The massive entry of women into the front line of industry turned the war effort into a national project. Wives, mothers, daughters, and sisters now participated in the construction of every bomber, every fighter, every engine. Their children were at the front, but the planes were out of their hands. Patriotism took shape inside the factories. Each rivet was a silent response to the arrogance of the enemy. Meanwhile, the Reich did the opposite. In Germany, the war effort was maintained with forced labor, operated under coercion, punishment, and terror. Jewish, Polish, and Soviet women were thrown into slave labor in underground factories in inhumane conditions. Unlike the American ones, they couldn't suggest improvements, they didn't receive training, and they weren't seen as part of the national project. They were seen as disposable. The result was predictable: internal sabotage, faulty parts, and a widespread collapse of quality control. The difference between the two approaches was soon reflected in the numbers. By 1943, the United States was already producing more than 8,000 aircraft per month with a mostly civilian workforce, and more than 310,000 of these civilians were women. Most of them had been housewives, primary school teachers, students, or clerks. Now they guided 12-meter aluminum pieces along industrial rails as if they had been born inside the factory. But the most surprising thing was not the female presence itself, it was his permanence. The 1943 German report predicted that quality would collapse within 6 months, through fatigue and inexperience. A year later, the women were still there, and the planes were better. The prediction didn't just fail, it was reversed. Production morale was higher, turnover was lower, productivity higher. This ability to silently adapt would become an invisible weapon in the conflict. Democratic flexibility overcame totalitarian rigidity. While the Luftwaffe saw signs of collapse where there was social innovation, America built, with the hands of its citizens, an air superiority that could no longer be ignored. And when the bombers flew over the underground factories of the Reich, they carried not only bombs but an uncomfortable truth. The enemy they mocked was winning with the very thing they despised. Such was the confusion that during an interrogation in 1945, a German colonel asked, "How did you stop the women from sabotaging the planes?" The American officer's response was short. They didn't want to sabotage. They wanted to win. But this quiet victory was still under construction. Because while the Reich slowed down, struggling to assemble a fighter in factories scattered across hundreds of hidden locations, America figured out how to unite all the elements of its factory model into a single concept: continuous production, interchangeable parts, moving lines, and real-time adaptation. The next part reveals how the multiplication of these factories and the coordination between states created a logistical nightmare for Germany, a war won not by the cannon, but by the rail, the conveyor belt, and the spreadsheet. In 1942, as the skies of Europe began to be streaked by Allied bombers, Germany began a desperate reorganization of its industrial infrastructure. The plan was to protect aircraft production by moving it to underground facilities. What seemed like a containment strategy turned out to be an engineering, logistical, and moral error. The so-called Jaeger program, led by Albert Speer, dispersed more than 700 factories through caves, abandoned mines, railway tunnels, and makeshift structures throughout the territory of the Reich. Enslaved workers, mostly prisoners of war and deported from the occupied territories, operated in conditions that made any technical standard unfeasible. The constant humidity damaged materials. Inadequate ventilation compromised the accuracy of the machines, and the sabotage, silent, spread like a virus. Gears disappeared. Screws were purposely poorly fixed. Planes took off and did not return. Meanwhile, on the other side of the Atlantic, the United States multiplied factories as if it were setting up a production network synchronized by a single brain. Seattle, Long Beach, Fort Worth, Chicago, Buffalo, Tulsa. Each city became a hub of assembly. Each pole followed standardized specifications, guided by technical documents reviewed in real time. Boeing, for example, started producing the B-17 in 4 different locations with completely interchangeable parts. The B-29 bomber, more complex and technologically advanced, was designed already modular. Its sections, nose, center fuselage, wings, tail, were produced separately and assembled like a jigsaw puzzle with minimal error tolerances. This allowed not only to scale up, but to absorb hundreds of design changes without interrupting the pace. In 1943 alone, Consolidated Aircraft engineers processed 578 modifications to the B-24 Liberator, and they didn't miss a single day of production. The Willow Run factory, a symbol of this technical miracle, adjusted its assembly line in motion. Literally, when an engineering error was discovered, engineers would create a solution and implement the fix on the line without slowing down production. This was unthinkable for the Germans. In Germany, each change required a memorandum, a party authorization, a hand redesigned, and weeks of waiting. In the United States, a new wiring harness could be installed on the next plane on the line. This flexibility was supported by a supply chain that functioned like a living body. IBM, through its punch card machines, tracked millions of components per day, distributed to thousands of suppliers. If a part failed, its origin was located, analyzed, and replaced in real time. It was the beginning of modern logistics, and it was designed for total war. While the Nazis piled up bodies to move boxes, the Americans organized boxes to save bodies. The dimension of the contrast is revealed in the numbers. By 1944, Ford, at its Chicago engine plant, was producing more airplane engines per month than all the underground plants in the Jaeger program combined. General Motors, operating under license, delivered 57,658 engines. Packard, another 55,000. Dow Chemicals increased magnesium production from 6 million to 333 million pounds. Alcoa increased its supply of aluminum by 600%. Each civilian factory that had been converted became a satellite of a national manufacturing constellation. Each bolt had a destination, each destination a precision. Germany, on the other hand, lost its industrial compass. The geographical dispersion designed to resist the bombardment resulted in irrecoverable delays. The pieces took days to arrive between the facilities. Many times they were not enough. The Luftwaffe began to fly hastily assembled planes with incompatible parts. Quality control collapsed. And when the plane crashed, they didn't know if the error was human, technical, or simply inevitable. This difference between standardization and improvisation was evident in the post-war accounts. A German engineer captured in 1945 revealed that the average time to adapt a change in a Focke-Wulf 190 fighter was 3 to 5 months. In the case of the American P-51 Mustang, changes suggested by pilots on assignment could reach the assembly line in less than 2 weeks. This speed of adaptation was in itself a strategic weapon. American industry didn't just produce more, it learned faster. The irony of this story is that the solution was in front of them. The Reich relied on steel, fear, and unquestioning orders. America relied on data, feedback, and testing. The method won over the muscle, and mathematics has overcome mysticism. If you're enjoying unraveling these facts accurately and thoroughly, show your support, like and subscribe so we can bring you more in-depth content like this. But there was still a critical piece to this industrial puzzle. The plane, as perfect as it was useless without pilots, and vulnerable without protection. The next part reveals the moment when the skies of Europe began to fill with flying fortresses, and how Germany discovered, too late, that the American Air Force was not only numerous, it was inexhaustible. In December 1942, in the sky over Tunisia, German pilots of JG-77 faced an enemy that seemed to have multiplied overnight. Between the clouds and anti-aircraft fire, Major Johannes Steinhoff observed what he later described as a carpet of bombers. They were no longer the amateurs of 1942. Americans now flew in close formation, armed, escorted, and above all, numerous. For the first time, the Luftwaffe felt what it was like to be overtaken by an air force with unlimited industrial logistics. Throughout 1943, this feeling would turn into certainty. The skies were changing owners, and the Germans knew it. On January 27th, 64 bombers of the U.S. 8th Air Force launched the first direct air offensive against German territory. Wilhelmshaven was the target. At first, the Nazi command considered the action symbolic, a test, a bluff. But 2 months later, the attacks came again, and with more strength. In October, in the episode known as Black Thursday, the United States lost 60 B-17 bombers in a single attack on Schweinfurt. It was a devastating loss for any conventional air force. But 2 weeks later, Germany's skies were again covered by brand new bombers, and this time, in greater numbers. Mathematics imposed itself. Aircraft production in the United States had reached a scale that Germany did not even understand. In 1943, the U.S. delivered more than 85,000 aircraft. The following year, the number would exceed 96,000. In that same period, Germany barely exceeded 30,000, and most of these planes never flew. Parts were missing. There was a lack of fuel. There was a lack of pilots. The Luftwaffe bled silently. Between February and March 1944, the U.S. launched the campaign known as Big Week, 5 days of concentrated bombing raids on German aircraft factories and logistics centers. There were 3,500 bomber sorties. The Luftwaffe lost between 260 and 350 fighters. But more critically, it lost about 100 of its most experienced pilots. Replacing them was impossible. Training a German pilot took months. Producing an American plane took days. Here it is worth pausing for a revealing fact. By 1944, America was producing 2,500 fighters a month, while losing only 400 in combat. Germany, on the other hand, lost 1,200 fighters and produced only 1,000. This cumulative deficit was not just tactical, it was terminal. If this number surprises you, comment, absolute power or logistics wins. Your reaction is part of our mission to keep historical memory alive through data. For the German drivers, the turn was visible to the naked eye. On missions over European territory, American formations of B-17 Flying Fortress and B-24 Liberator stretched from horizon to horizon. Some missions involved more than 1,000 bombers, escorted by hundreds of P-47 Thunderbolts and, later, lethal P-51 Mustangs. Major Heinz Baer, one of the Luftwaffe's greatest aces, described a January 1944 mission as a flying metallic wall. In his words, there were 8 of us, against hundreds. It was desperate. And when a German fighter managed to shoot down a bomber, he knew that plane would be replaced in a matter of days. There was no victory. There was only delay. Contrary to what Hitler believed, the presence of women in factories did not indicate collapse. It indicated breath. And it was exactly this breath that kept American production lines supplying 2 theaters of war simultaneously, Europe and the Pacific, while Germany could barely sustain the Eastern Front. The constant losses in the air began to compromise the very structure of the Luftwaffe. Veteran officers like Galland, Steinhoff, and Baer not only recognized American air superiority, they feared it. In internal reports, they warned of the inevitability of defeat if the Reich failed to numerically compensate the bombers. But there was no more time. British air bases received weekly reinforcements, new models, new squads, new drivers, and with them, a new doctrine: continuous attack. The U.S. 8th Air Force maintained almost daily sorties over strategic targets. When Germany retreated its factories underground, The Americans bombed the railway lines, the distribution centers, the power plants. It was all-out war by air, and it was sustainable, only for those who had absolute logistical control. This change was not only quantitative, it was qualitative. American bombers came equipped with motorized machine gun turrets, Norden sights, radio navigation systems, and reinforced armor. American fighters, such as the P-51, incorporated advanced aerodynamics, extended autonomy, and superior armament. Technology, combined with volume, created a new paradigm of warfare. Germany, even developing the revolutionary Me-262 jet fighter, could not field it on a sufficient scale. Only 400 units were produced, and fewer than 300 ever operated simultaneously. In 1944, German losses reached an irreversible point. The factories were damaged, the pilots exhausted, and the heavens lost. In July of that year, the Americans launched attacks by day, while the British bombed by night. The Luftwaffe, once feared, could now barely respond. General Adolf Galland wrote in a confidential report, "The Luftwaffe is bleeding to death, and the heavens belong no more to us." But the war was not yet over, and the American industrial climax was yet to come. In the next chapter, we will see how a single factory, isolated in the middle of the American countryside, surpassed all the war air capacity of the Third Reich, a place that started with discredited promises and ended up as an absolute symbol of the productive superiority of the United States. By mid-1944, the war in Europe was no longer defined by tactical maneuvers or inflammatory speeches. It was an accounting operation on a continental scale, and Germany was losing in mathematics. The Luftwaffe, once a symbol of German air power, saw its statistics become sentences. For every 1,000 planes produced per month, 1,000 were lost. In combat, in accidents, due to manufacturing defects or simply due to lack of parts. The pace of losses exceeded that of replacement. It was an industrial bloodletting. Meanwhile, the United States, operating as a continental precision machine, was producing 2,500 fighters monthly and losing fewer than 400. For every American plane shot down, 6 others appeared. With each squadron replaced, 3 new ones appeared. With better trained pilots, more modern planes, full tanks, and tuned radios, the war became an equation, and in it, the side with the most fuel, the most aluminum, and the most riveters prevailed. This numerical superiority was only the surface. Behind it was the invisible logic that Nazi ideology never understood. The United States didn't just produce more, it produced better and faster. A factory in Dallas was able to retrofit an entire assembly line within 72 hours of receiving a new batch of redesigned parts. At Oklahoma, the production of modular airframes allowed for the replacement of damaged sections in the field, reducing downtime to less than 36 hours. Meanwhile, Luftwaffe mechanics needed 5 days to replace a landing gear, damaged by a lack of spare parts. With each bombing mission, the United States mobilized more than 1,000 aircraft, with precision for refueling, replacement, and repair. In all, between 1942 and 1945, the Americans dropped more than 2 million tons of bombs on Europe, 200,000 attacks, millions of liters of fuel, thousands of kilometers of air routes coordinated in real time by radio and onboard radar systems. It was a logistical engineering that seemed invisible to the eyes of the German generals, because they still believed that the war was won with ideology, will, and race. But the data did not lie. The war was won with torque, octane, aluminum, margin of error, and efficiency calculations. Each week, the Allied forces received about 700 brand-new combat-ready planes. Each week, the Luftwaffe saw its numbers drop, and there were no more resources, reserves, or miracles. The Me-262, the revolutionary German jet fighter, arrived late in a few units and without enough kerosene to fly more than 2 missions. The P-51 Mustang, with extended range and versatile weaponry, covered round-trip missions from England to Berlin, escorting bombers like a tireless sheepdog. On paper, the German doctrine still spoke of technical victory, but in the Pentagon's spreadsheets, there was talk of an air saturation curve. The difference was in mentality. The Luftwaffe responded heroically, the USA, with numbers, and the numbers were crushing heroism. By March 1945, monthly American aircraft production reached 9,000 units. That same month, Germany produced 2,200, and he lost 2,300. The Luftwaffe had become statistically invisible. The most ironic thing is that during the first years of the war, Hermann Göring said with conviction that democracy was structurally incapable of organizing itself for combat. He said that Americans were good for refrigerators, not bombers, who knew how to assemble cars, not fight wars. But reality imposed another truth. The people who built cars learned to assemble fighter jets. And he assembled them so efficiently that the war ceased to be a soldier's fight and became a succession of shipments. The United States has made production a strategic act. The spreadsheet became a weapon, and the spreadsheet does not respect speeches. He does not bow to uniforms. The spreadsheet just adds up, and in 1945 it added to the side of the stars. A German engineer captured in April of that year was blunt. We had ideas, they had methods, and the methods won. But there was still one last chapter to be written, the moment when Hermann Göring himself, the man who once laughed at the promise of 50,000 planes, watched the skies of Germany darken under the roar of hundreds of them. In the next part, the final irony, when laughter met the echo of the propellers. Between January and May 1944, Germany's skies became an unowned territory. Every cloudy morning or sultry afternoon, the deep sound of distant engines announced the arrival of the new enemy. Invisible, impersonal, relentless. They were not soldiers, they were planes. And they did not come to conquer ground but to silence machines. The United States, now with total logistical and industrial dominance, dropped 145,000 tons of bombs on strategic targets inside the Reich. But the real goal was not visual destruction. It was the invisible collapse. The impact was less on the rubble and more on what stopped spinning. Factories that produced engine bearings stopped delivering. Refineries were paralyzed for weeks. Railroad depots burned, disrupting the delivery of parts between the already fragmented underground German production lines. The plan was simple: kill the machine from the inside. The bombs hit nerve centers: Linz, Essen, Leipzig, Schweinfurt, Merseburg. Targets chosen not for their symbolic value but for their role in the war equation. Schweinfurt, for example, produced 52% of Germany's ball bearings. In 2 weeks, its capacity was reduced by 70%. Without these bearings, tanks did not run. Engines did not work, propellers did not rotate. In Merseburg, the liquid hydrogen plant, essential for the synthetic fuel, was hit 5 times in 40 days, and each outage required weeks to repair. In a system where there were no spare parts anymore, German engineers began to report failures that were no longer localized, but systemic: assembly errors, absence of standards, accumulated defects. The collapse was not immediate, it was progressive, and therefore, more lethal. In the confidential reports of the Ministry of Armaments, written under the supervision of Albert Speer, the first signs of despair appear. Between February and March 1944, tank production fell by 38%. Production of trucks, vital for transportation and refueling on the front lines, fell by 41%. Military aviation, already weakened, lost 33% of its replacement capacity. An engineer in the air maintenance sector wrote, "We are operating with 60% of components that should be discarded." Speer himself would acknowledge in his post-war testimony that the war was being decided not in the trenches, but in the production sheets. American logic was brutally efficient. The factory, the electric transformer next to it, the railroad bridge 5 kilometers away, the wagon marshalling yard were bombed. Each mission was calculated to reach the supply chain, not just the final product. It was like cutting off the oxygen of a body that was still conscious. A Luftwaffe colonel wrote, "The factories are standing, but the trains are not enough. The parts are ready, but the engines do not fit. The men are ready, but the planes don't turn on." Germany was being asphyxiated in slow motion. Meanwhile, the United States operated under maximum redundancy. If one factory was damaged, another took over the delivery. If a part was affected, another line replaced it. Ford duplicated production lines. General Electric took over delayed supplies from Westinghouse. The system worked like a hydra. One head was cut off, 2 appeared. And this resilience was underpinned by something the Reich never valued: decentralization with coordination. Democracy, which Göring despised as disorganized, turned out to be more adaptable, more responsive, and therefore more powerful. Allied intelligence reports began to indicate the cumulative effect of the campaign. The ammunition factories worked with minimal stocks. The Luftwaffe began to reuse damaged components. Officers complained about the drop in the quality of parts, the misfire in new engines, the increase in hydraulic failures in newly assembled aircraft. The technical cycle of the German war machine, which once prided itself on its accuracy, was being eroded from within. The gear did not stop turning, but it was already creaking. And then, the inevitable statistic. In July 1944, Allied bombing destroyed 90% of Germany's fuel refining capacity. The tank army stopped. The Luftwaffe was left on the ground. The Navy was reduced to defensive patrols. Hitler ordered fuel rationing even for high-ranking officers. The war economy collapsed. The war has become, in fact, a race between assembly lines. And in that race, the United States was already crossing the finish line, while Germany was looking for shoes. Speer, months before his arrest, confessed in a closed meeting, "We lost the war the moment they decided to bomb our factories, not our soldiers." And he was right, because the next step would not come from the sky. It would come from the ground. The occupation was approaching, and along with it the final revelation. When American soldiers stormed German factories still in operation, they discovered a truth that would shock even the most optimistic on the Allied side. The enemy was not only defeated, he had already stopped fighting. While Germany was trying to maintain its air supremacy with the Me-262 jet fighter, built in small quantities, under constant shortages of materials and industrial sabotage, the United States was already operating on another technological plane. In 1944, Boeing began delivering the first examples of the B-29 Superfortress, the most advanced bomber ever conceived. More than an aircraft, the B-29 was a statement of intent. Pressurized with transcontinental range, machine gun turrets controlled by a computerized targeting system, and a fuselage developed entirely in modules, it represented the pinnacle of scale-driven warfare engineering. Each unit carried more than 1 million parts, distributed among factories in Kansas, Nebraska, Georgia, and Washington. 4 states, 1 aircraft, assembled with a tolerance of hundredths of a millimeter. The Me-262, as advanced as it was in concept, could not even take off without risk of engine failure or hydraulic failures. The B-29 crossed oceans. The total investment in the B-29 project exceeded $3 billion, more than the Manhattan Project itself. While Germany was barely able to refine the steel needed for the landing gears of its aircraft, the United States developed special alloys for the B-29 to operate at altitudes above 9,000 meters, unreachable for most enemy fighters. And the logic of modular production, established by Knudsen, now reached perfection. Each section of the fuselage was manufactured separately, transported by rail, and assembled in a few hours in assembly centers such as Renton's Base in Washington. The B-29's electrical system had more than 14 miles of wires. Its Wright R-3350 engines, an 18-cylinder Colossus, required temperature controls calibrated by automatic sensors, and its pressurized cabin allowed for long flights without the need for oxygen masks, reducing crew fatigue and allowing for more precise missions. The Norden sight, coupled to the automated bombing system, allowed hits with a margin of error of less than 100 meters from 9,700 meters of altitude. No Luftwaffe bomber has even come close to this level, but the real innovation was not just in the aircraft, but in the ecosystem that underpinned it. The logistics involved in the production of the B-29 required coordination among thousands of suppliers. Curtiss-Wright manufactured the engines, Goodyear, the wheels, Sperry, the navigation systems, and each component was tracked by punch card systems that anticipated supply problems weeks in advance. If a gear failed, a new supplier was called in before production was stopped. Such a network of technological resilience was simply unthinkable under the centralized and rigid logic of German industry. Meanwhile, in the Reich, the Me-262 was facing its own logistical tragedy. Only 2,400 units were assembled. Less than half even flew. Many were destroyed on the ground due to lack of parts or fuel. Others have never received adequate pilot training. The Junkers Jumo 004 engines, pioneers of jet propulsion, had a service life of only 25 hours. By comparison, the B-29's engines could operate for more than 200 hours before the first maintenance, and the Me-262's practical range was less than 1,000 kilometers, making it a local, not strategic defender. The B-29, on the other hand, could hit targets 5,000 kilometers away and back, without refueling. This difference was not just in numbers. She was philosophical. The Reich invested in isolated revolutionary weapons, betting on wonder weapons. The United States invested in integrated systems. The B-29 was not a technical miracle. It was the tip of a chain of logical, coordinated, and measurable decisions. Its entry into operation, first in the Pacific, then in Europe, marked the beginning of a war in which the sky was no longer contested territory, but occupied. In command of the mission, General Curtis LeMay changed the doctrine from high-altitude bombing to low-altitude incendiary bomb attacks. The B-29 proved its flexibility. From strategic precision, it went on to industrial terror in Tokyo, and the irony was brutal. While the Germans still dreamed of regaining air superiority in Europe, America was already destroying cities on the other side of the planet with planes that flew higher, farther, with more cargo, and returned. A German officer captured in the spring of 1945 made a bitter remark. While we were discussing secret projects in bunkers, they were building planes en masse, flying over our heads, and ignored us. It was the recognition that the American leap wasn't just in technology, it was in mindset. While Germany bet on the miracle, America relied on engineering, but the B-29 still held a final role, a role that would change not only the war, but the history of humanity. In the next chapter, we'll see how this same bomber, born out of the four-state manufacturing effort, would carry the most destructive weapon ever created, and it would end the war with a bang that no general foresaw. Modern warfare, as few realized at the time, would not be won by bravery or technology alone. It required something more subtle and more lethal: adaptation. In the United States, every mission, every failure, every field report was treated as raw material. When B-17 Flying Fortress pilots began reporting mounting losses due to Luftwaffe frontal attacks, the response was not a memorandum or an evaluation committee. In just 60 days, Boeing had already redesigned the nose of the aircraft to include additional machine gun turrets, reinforcing the blind spot that enemy fighters exploited. The result was immediate: a significant reduction in losses and an increase in confidence in the crews. The chain was straightforward: battlefield, engineer, assembly line. There was no military bureaucracy, but flow of data and decisions. In the Pacific, the need was different: range. The distances between Allied bases and Japanese targets required planes with greater autonomy. The B-24 Liberator, with its lighter design and additional tanks, was modified at full production pace for 4,000-kilometer missions, without interrupting the line, without stopping the factory. Adaptation was no exception, it was routine. General Motors even altered the internal design of a fighter based on suggestions from field mechanics, who realized that the arrangement of the cables made repairs in combat zones difficult. These changes came on the line in less than 3 weeks, and this speed of change was present at all levels. Workers on the factory floor, many of them without technical training, were heard by the engineers. A worker at the North American plant suggested that the riveting tools be redesigned for better grip. The idea was accepted and standardized on all lines of the Mustang P-51. It was an industrial culture of active listening and immediate reaction. Democracy, so often ridiculed for its supposed disorganization, revealed its greatest strength: agility. Meanwhile, in Germany, the scenario was different. Each modification to aircraft required technical validation, approval from the high command, and finally, political authorization. A simple suggestion to change the shape of a Messerschmitt fighter's canopy could take 6 months to get off the ground, and when finally approved, it was often unfeasible to implement in underground factories, already overwhelmed by extreme conditions and internal sabotage. The ideological rigidity of the regime was reflected in the inability to change. The Nazi doctrine relied on initial perfection, on immutable design, on order that admits no failure. By 1944, American engineers had implemented more than 500 modifications per month to their aircraft. In the Luftwaffe, the average was 20, and this in times of total emergency. One piece of data that sums up this disparity: the average time to adapt a new machine gun to the nose of the P-47 Thunderbolt was 18 days. On the Focke-Wulf 190, an equivalent modification took 116 days to reach combat units. If this statistic surprised you, comment with "shocking data." The same pattern was repeated in tanks, trucks, radios, uniforms, and even field rations. If soldiers complained about the difficulty of opening the supply cans, the design was changed. If camouflage did not work in a certain theater of operations, New tissues were sent. It was a war that I heard, a war that corrected, and therefore a war that was advancing. The Germans, on the other hand, spent resources trying to force their ideas on a reality that had already changed. The Heinkel He-219 fighter project, for example, took almost 2 years to leave the testing phase due to internal disputes in the Luftwaffe command. By the time he finally reached the front lines, it was too late. Air superiority had already changed sides. The war was already decided by who reacted the fastest, and not by who had the best initial idea. And it wasn't just about physical production, it was a change of mentality. Americans cultivated error as learning. The Nazis punished him as weakness. The US tested, failed, corrected, improved. Germany insisted, repressed, concealed. This difference, invisible in the trenches, was devastating in the spreadsheets. This agility of democracy, often dismissed as inefficiency, has proved to be the most powerful invisible weapon of conflict. And while the eyes of the world were still focused on the fighting on European soil, a new gear was being activated in the Pacific. A project of a scale as monumental as it is secret, where adaptation would cease to be just technical and would become nuclear. In the next part, we will see how the combination of science, industry, and planning would culminate in the most destructive weaponry ever created by humanity. And once again, it would be the Americans who would deliver it. Flying. After the war, sitting in an American cell and no longer in uniforms to flaunt, Hermann Göring was no longer the air marshal. He was just a man facing reality that he tried to ignore. In interrogations conducted by Allied officers, the tone was no longer one of denial, but of intellectual surrender. Göring, who had once laughed at the American goal of 50,000 planes a year, now asked for reports. I wanted numbers. He obsessively compared the production of Willow Run with that of the entire Luftwaffe. He asked detailed questions about the modularity of the B-24s, the assembly deadlines, the shifts of workers. I knew they had industrial potential, he admitted, but the execution trumped everything. In his testimonies, he rarely tried to justify German superiority. On the contrary, he sought to understand how they were overcome with such forcefulness. Göring was not alone. Other captured generals, such as Albert Kesselring and Johannes Blaskowitz, gave similar testimonies. None of them credited the defeat solely to the battlefield. Everyone mentioned the invisible machine behind enemy lines. It wasn't just the planes, said a Luftwaffe colonel, but the speed with which they returned to combat. For every Bf-109 shot down, it was necessary to wait weeks. For every P-47 shot down, 3 appeared the next day. The difference was in what they called the line of return. The Germans had pilots but no parts. They had hangars but no fuel. They had doctrine but no replacement. What started as laughter turned into obsession. Göring requested maps of American factories, studied production systems, tried to find retroactive flaws, justifications that never appeared. They hit where we never even looked, he would confess to a British interrogator. It was the bitter recognition of a technical defeat, not just tactical, not strategic, but systemic. In the interrogation documents, one fact was underlined several times by German officials. The average replacement of American bombers was 14 days. In Germany, this number exceeded 70 days, when parts were available. Another oft-cited number, the US was able to standardize more than 80% of its aircraft components in 1944. Germany, with its multiple decentralized suppliers, was no more than 20%. The consequence was clear. While the Americans assembled, the Germans repaired. While the Allies flew, the Nazis waited. There was also the human factor, another point that impressed the captured officers. Göring, in particular, was astonished at the efficiency of American civilian workers. How does a democracy achieve factory discipline? He asked. The answer, he himself acknowledged, lay in the pre-existing industrial culture. Americans did not learn to produce in war. They only adapted civilian production to the war effort, and they did so with such speed that the Reich did not even have time to react. In a recorded conversation with a French officer, Göring reportedly said, "We did not lose to the American soldiers. We lost to their workers." It was more than a catchphrase. It was the epitaph of a doctrine that underestimated the value of an assembly line, the importance of technical listening, and the moral strength of a plural society, which learned to build bombs, planes, tanks together, and consensus. The German generals no longer discussed defeat. They understood her. And this is perhaps the most telling thing about what happened between 1940 and 1945. The enemy who started laughing ended up calculating, and even with the numbers in hand, it was already too late. In the next part, we'll dive into this universe of data, where war has gone from being epic to being statistics, and we'll understand why. For every bomb dropped, there was a precise number behind the impact. When military historians analyze the American war effort, it is common to highlight Sherman tanks, B-17s, the Normandy landings, or the atomic arsenal. But the real center of gravity of victory lay where few look, in the bureaucracy, the one the Germans so despised. Contrary to the Nazi imagery, which saw democracy as a chaotic, weak, and slow system, the United States created between 1942 and 1945 the largest civic organization machine in modern history. Behind each fighter plane there was a form, behind each tank a contract, and behind each operation a committee, made up of civilians, engineers, technicians, and workers, all coordinating a gear on a continental scale. This invisible structure was orchestrated by agencies such as the War Production Board, which regulated the use of raw materials, the Office of Price Administration, which controlled inflation and domestic consumption, and the legendary Office of Scientific Research and Development, which connected universities to the war industry. There was no waste. Every gram of aluminum, every liter of fuel, every centimeter of steel was accounted for, redirected, and reused. It was the antithesis of the Nazi system, where technical decisions depended on political favoritism or the approval of Hitler, who often delayed or paralyzed projects on a personal whim. In the United States, businessmen have become generals of production. Men like Henry J. Kaiser, who revolutionized shipbuilding by introducing welding instead of rivets, reducing the time to assemble a cargo ship from 250 to 7 days. Or Donald Nelson, who stepped down as president of Sears to head the War Production Board, reorganizing supply chains and making sure one plant in Pittsburgh knew exactly what to deliver to another in San Diego. It was a logistical war, won by spreadsheets and ordinary people. And this machine did not work by coercion, but by coordination. The American people were called to participate, and they responded. Millions of citizens bought war bonds, recycled metals, adjusted consumption habits, worked in 3 shifts. Democracy, with all its imperfections, had proven capable of disciplining itself when threatened. Freedom was not an obstacle. It was the fuel. The Germans, for their part, never understood this phenomenon. For them, organization could only come from the top down. The concept of a free society self-regulating to win a war was simply unthinkable. A 1943 Nazi intelligence report, recovered after the conflict, literally said, "American production depends on voluntarism. It's not sustainable." But it was, and it was. In 1944, airplane production reached its peak, almost 100,000 units delivered in a single year. In the same period, Germany produced fewer than $40,000, and many of these planes did not even leave the ground. The underground factories were isolated, the transports collapsed, the workers exhausted. Meanwhile, in the United States, additional shifts were opened to speed up deliveries. The engine of democracy, silent and invisible, was spinning with maximum force. And here is one of the most brutal ironies of the Second World War. The same men who laughed at democracy were defeated by their ability to organize. Göring believed that the American people were soft, consumerist, incapable of sacrifice. But it was housewives who assembled the engines that destroyed their tracks. They were students who collected scrap metal that became ammunition for the bombers. They were migrants who crossed the country to work in factories, unaware that they were drawing the end of the Reich. A 1945 U.S. report showed that for every German division deployed to fight, the U.S. could move twice as much ordnance in half the time. Time, more than force, became the decisive weapon. And this weapon was forged not on the battlefields, but in the minutes of meetings on the drawing boards and in the logistics centers spread across 48 states. This is the point where war changes language. It stops talking about strategy, tactics, or armaments, and starts talking about railroad routes, regulatory stocks, production targets. It was there that democracy, with its initial slowness and its multiplicity of voices, showed its ultimate strength, the ability to listen, correct, adapt, and execute. But the American civic power had not yet revealed its last letter. In the next chapter, we will see how this same machine, disciplined, coordinated, and silent, would be tasked with delivering a cargo that weighed not tons, but rather the fate of an era, and the world, seeing it fall, would never be the same again. In 1942, as Europe sank into rubble and tyrannies roared orders with clenched fists, the United States was conducting a singular experiment, winning an all-out war without compromising its own principles. The War Production Board, created to coordinate the industrial effort, managed 300,000 companies in the United States. It was not a centrally commanded economy. It was a network of collaboration, where trade unions, universities, businesses, and even small businesses adjusted their rhythms to the tide of war. IBM, still far from what it would become post-war, used its first mechanical tabulation systems to track millions of parts, cross-check inventories, and feed assembly lines with minute accuracy. It was an industrial symphony played without a whip, without terror, without mandatory uniforms. Unlike Nazi Germany, where critical decisions were made by ideological fidelity or personal whim, in the U.S., efficiency was the absolute criterion. The unions, which had previously fought hard for labor rights, agreed to suspend strikes until the end of the conflict. In exchange, the government guaranteed decent wages and minimum security conditions. It was a moral pact, not imposed, but accepted, and it worked. Universities, in turn, have set aside traditional curricula to train engineers, chemists, and metallurgists in record time. MIT, Harvard, Berkeley, all integrated into projects of direct application in the war effort. In the neighborhoods, communities organized themselves to collect tires, cardboard, aluminum. Children delivered newspapers. Housewives sewed uniforms. Farmers adjusted crops to supply the fronts. And all this without an apparatus of coercion. "The machine didn't roar," she whispered. And it was in this silence that his strength lived. Moral force became logistical force. The world, accustomed to regimes that screamed to appear strong, was not prepared for a society that obeyed out of conviction. The Nazis, unable to understand this social fabric, interpreted it as weakness. They thought that a country that heard so many voices could never march in the same direction. But it marched, and more accurately than any Reich military parade. In 1943, the number of civilian workers directly involved in war production in the U.S. exceeded 20 million. Of these, 6 million were women. Nearly one-third were African American, Latino, or immigrant. It was an army without rifles, but with wrenches, technical pencils, and 12-hour shifts. A force that was not obligatory, but voluntary. The irony of this story is that the solution was in front of them. While the Reich sought efficiency with steel and fear, American democracy sought results with coordination and trust. If you're enjoying unraveling these facts, show your support. Like and subscribe so we can bring you more in-depth content. Because these stories, often invisible, have shaped the world. And although the war was not yet over, the signs were clear. Allied convoys crossed the Atlantic in record times. Bombers flew in swarms calculated to the second, and supply lines were as extensive as they were accurate. But the real proof of American logistical supremacy was yet to come. A day, a location, an operation that would require everything: men, machines, and the mathematical coolness of war engineering. In the next part, we will see what happens when 156,000 soldiers have to cross an ocean and land in hell. As tanks crisscrossed Normandy and bombers tore through the skies of Europe, far from the front lines, another troop, silent, disciplined, invisible, sustained the offensive. There were more than 2 million workers spread across the aeronautical factories of the United States, men and women, young and old, whites, blacks, Asians, Latinos, refugees from the war, and children of the Great Depression, all united by a common cause, to win a war that, although far from their homes, was felt in every tight rivet, every engine assembled, every extended shift. Unlike Germany, where the war industry was sinking into dependence on slave labor, forcibly taken from concentration camps, occupied territories, and political prisons, the United States built its planes with citizenship. It was democracy converted into a driving force, and it worked. Factories that employed women, for example, had lower error rates and higher productivity rates. Those that integrated African Americans and immigrants had lower turnover. Plurality, seen by many as a weakness, proved to be advantageous in practice. Rosie the Riveter would become a cultural icon, but behind her were hundreds of thousands of other Rosies, some black, some Hispanic, some with names the newspapers couldn't pronounce. They worked side by side, often with no previous history on the factory floor. Trained in weeks, they adapted to complex procedures, often faster than veteran auto industry workers. The reason? Commitment. Each piece put together was a protest against what Hitler preached. Each bomb built was a response to the idea that only one race was worth fighting. At Douglas Aircraft, Boeing, North American Aviation, internal reports showed significant efficiency gains as more minority groups were integrated into the effort. The industry did not just produce, learned. And this happened because the system was flexible. Engineers listened to suggestions from workers. Supervisors adapted rhythms according to the team's profile. Assembly lines were not armies. They were living organisms, where experience and intuition met. Meanwhile, in Germany, the situation was the opposite. As the Reich lost territory, it relied more heavily on forced labor. Jewish children, Russian prisoners, Polish women, all subjected to grueling hours, under armed surveillance, without technical knowledge and worse, without motivation. Sabotage became routine. Engines were assembled with loose screws, parts damaged on purpose, hidden components. In 1944, it was estimated that 10% of failures in German fighters came directly from acts of industrial sabotage. The difference was not just moral, it was functional. Airplanes produced by free workers flew more, and they lasted longer. With each successful mission, morale in the factories increased. The newspapers published photos of the aircraft baptized by the workers. Many placed cards inside the panels, wishing the pilots luck. It was a war with a soul, and the soul came from someone who never imagined wielding a weapon, but discovered in the factory routine a trench as essential as those at the front. At the Lockheed factory, for example, it was a blind employee who suggested a change in the texture of internal fittings when she noticed, by touch, irregularities that the machines did not detect. At another unit, in Kansas City, a 58-year-old worker identified an alignment failure in landing gear that prevented a serial accident. These stories, previously relegated to the footnotes of reports, began to be recognized. Unions began to publish bulletins highlighting individual contributions. It was the war of competence, not propaganda. Productivity skyrocketed. In 1941, it took a factory 200 hours to assemble a medium bomber. In 1944, the same model rolled off the line in 60 hours, and this with more quality. The rate of return for repair has dropped by almost 40%. The secret? People, not slogans, not dogmas. Only ordinary people, empowered, respected, listened to. And here, once again, historical irony imposes itself. The regime that boasted the most discipline was superseded by a society that chose to collaborate. The system that claimed to be superior, because it excluded the undesirables, fell before a structure that won precisely because it included them. Every American plane was a statement of values, not only for what it destroyed, but for those who built it. And if you've come this far, feeling that same admiration for these invisible hands that changed war, know that it's thanks to them that this story can be told. Like, share, and subscribe if you want to see more stories like this being recovered with the respect and depth they deserve. Because in the next part, we're going to look at the moment when these millions of bolts, plates, rivets, and ideas took shape in the largest amphibious assault in history. The day production became a landing. The day logistics stepped on the sand of France, Willow Run, Michigan. It was just a rural extension forgotten on the map, until, in 1941, Ford decided to erect a structure there that most Nazi generals would classify as an American fable. On paper, the goal sounded absurd: to produce heavy bombers, the B-24 Liberators, at an automotive pace. An 18-ton aircraft with more than 1 million parts, which previously took months to complete, was now supposed to roll off the assembly line every few hours. At first, as we have seen, it was a cause of derision. Will it run? Scoffed the skeptics. But in April 1944, the answer became unequivocal. Willow Run peaked. One bomber finished every 63 minutes, 24 hours a day, 7 days a week. The magnitude was incomprehensible. The factory operated with uninterrupted shifts, employing more than 42,000 people. The main building was nearly 1.5 kilometers long, with an L-shaped assembly line designed for aircraft to be finished facing east, ready to take off toward Europe. Each section of the bomber was assembled into specific stations: nose, Wings, fuselage, tail, all prefabricated, fitted, tested. Workers were trained in highly specialized tasks. Tools were calibrated to exact functions. Everything standardized. Everything synchronized. And most impressively, Willow Run alone surpassed Germany's total air output. In raw numbers, there were more than 8,600 B-24 bombers produced between 1942 and 1945 in this complex alone. By comparison, the Luftwaffe, pressured by bombing raids and broken logistics, has never been able to maintain an equivalent average, not even with light fighters, let alone heavy bombers. Germany, as late as 1944, was struggling to maintain a functioning supply chain between factories spread across 700 different locations, many in caves, abandoned mines, and makeshift bomb shelters. In contrast, the United States centralized, standardized, and protected its facilities. Göring, upon learning of the reports about Willow Run, initially doubted it. According to the interrogations conducted after the war, the air marshal even asked for independent verification of the data. When he finally saw the American propaganda films, showing the assembly lines, the civilian workers, and the fluidity of the process, he was just silent. No bravado, no joke, no comments. The man who had laughed at the idea of 50,000 airplanes now watched, on a full screen, the assembly line that manufactured that number and more clockwise. But Willow Run was more than a factory. It was a symbol. It was proof that the impossible could be assembled, adjusted, painted, and shipped on an industrial scale. It was the line between skepticism and surrender, between the plan and the execution, between laughter and silence. Each plane that left there carried not only bombs, but the weight of a promise kept. There were reports of pilots who, as they flew over the industrial zones of the Axis, knew that their aircraft had been made by civilian hands, in a democratic system, far from coercion, and they felt this as a moral shield. Each B-24 launched into the skies was the negation of the authoritarianism that Göring defended, not by rhetoric, but by mathematics, and the impact was cumulative. As the Luftwaffe watched its fleet shrink, the U.S. Air Forces increased the volume of missions, expanded targets, tested new tactics. Willow Run allowed for this elasticity. It allowed boldness. It allowed mistakes, because there was substitution. A war that was previously fought by strategy was now also decided by replacement. The Nazis had bet on the wrong horse. They thought they would win by fury. But war, after all, belonged to engineering, to production, to persistence. Willow Run was the altar where that truth materialized. And if this was the grave of arrogance, what was left? In the next chapter, we will see the moment when industry bends to morale, and the machine built by engineers, workers, and citizens will be used to brutally and definitively end the greatest war in history. When the guns finally fell silent in 1945, the sound that remained was not the echo of the bombs, but the continuous hum of American factories. Unlike the industrial ruins of Europe, America's infrastructure didn't just survive, it thrived. Willow Run, which had been the greatest symbol of destruction on an industrial scale, became an automobile factory. Aluminum foundries that forged wings now shaped beams for bridges and rails for trains. The assembly lines that delivered bombers began to assemble refrigerators, tractors, civilian engines. What had been a war effort metamorphosed into a basis for peace. And perhaps without realizing it, the whole world began to operate in patterns created under the pressure of conflict. The technological legacy was visible in every corner of everyday life. Quality control, standardized and perfected under military requirement, was now applied in toy and household appliance factories. The automation, refined to reduce human error in the production of sensitive aviation components, has been adapted for civilian lines of consumer products. Logistics, which had learned to move tanks, ammunition, and planes across oceans, now supplied supermarkets, department stores, and distribution centers. War had birthed the era of efficiency, but it was not only the machine that evolved, it was the people. The female workers who riveted fuselages became a symbol of female independence and initiated an irreversible change in the role of women in the economy. Black workers, hitherto excluded, had shown their technical competence and began to claim, rightly, a place of equality in Reconstruction. The diversity that the Nazis despised turned out, ironically, to be the greatest asset of industrial democracy. While the Reich sank in ideology, the United States emerged in applied plurality. At universities, Engineers who designed B-29 bombers turned to the skies in another direction. They created the first prototypes of orbital rockets. Many of the modular integration processes applied to the assembly of airplanes during the war were carried directly into the first space programs. The leap from World War II to the space race was not ideological, it was technical, and it started on the drawing board of factories like Willow Run, Boeing Field, and Glen Martin. Economically, the impact was devastating for the rest of the planet. While Europe rebuilt destroyed cities, the United States rebuilt markets. The world needed products and the US knew how to produce them. Fast, cheap, standardized. The same model that delivered 100 planes a day now delivered thousands of cars, tons of canned food, miles of fabric. The Marshall Plan brought these products to a hungry Europe and established American leadership not by force but by logistics. When looking at the data, the picture is irrefutable. Between 1939 and 1945, the U.S. multiplied its industrial capacity by more than 5 times. By the end of the conflict, they produced almost half of all manufactured goods on the planet. The productivity of the workforce had doubled, and perhaps most symbolically, the mentality of rapid adaptation, which allowed you to move an assembly line from one fighter model to another in days, became the norm. A new era was dawning, no longer of total war, but of total production. And here's the ultimate paradox. America, in preparing to destroy, has figured out how to build. The conflict forged not only weapons but tools, management models, technical education systems, quality protocols, integration processes. Everything that had been gathered to defeat Hitler now fed civilian hospitals, schools, roads, and factories. The American industrial miracle was no exception. It was the beginning of a century, and for those who mocked, silence remained. In 1946, during an international engineering congress in Paris, a former German officer bitterly declared, "They did not win only with soldiers, they won with screwdrivers." Because in the end, that's what defeated the Reich, the precise gear, fed by a free people. But a number is still missing. The final number, the last statistic that Hermann Göring would never have imagined. And it is for her that we will end this story. Göring laughed because he thought it impossible that a fragmented plural and voluntary democracy could match the rigor of an authoritarian war machine. He saw freedom as an obstacle, in diversity, a noise, in decentralization, a sign of weakness. But that's exactly where it went wrong, and it was fatally wrong, because while the Luftwaffe imploded under the weight of authoritarianism and rigidity, the United States responded with adaptation, precision, and volume. It was not a general nor a tactic, nor a secret weapon that defeated the Reich. It was an assembly mat that did not stop. It was a dawn shift in Michigan. It was a riveter named Rosie. He was an accountant who organized pieces in spreadsheets. It was an entire country operating in sync, not out of fear, but out of purpose. In the end, the thesis is confirmed with brutal clarity. Industrial power did not only win, it rewrote the course of the war. Logistics won over ideology. Mathematics won the shout. And from this productive avalanche, the definitive lesson emerges. Modern wars are not only won on the battlefield, they are won on the field of production. Whoever controls the numbers controls the time, and whoever dominates the time decides the outcome. Strategies may fail, tactics may change, but logistics is the backbone of any victory. While Germany wallowed in incomplete projects, decentralized factories, and grandiose promises, America piled up results. One plane, then another, then another. Volume trumps accuracy. Regularity trumps brilliance. Flexibility wins over dogma. The final sentence did not come from a soldier. It came from Hermann Göring himself, in Nuremberg, when there was no longer any laughter, only a realization. We were defeated by a country that knew how to manufacture refrigerators on a large scale. And that is the irony that remains. The war he imagined winning with steel and blood was lost to aluminum and spreadsheet. And if you value this research, this reconstruction of the facts that books don't always tell, like this video, subscribe and activate the bell. Here, each piece of data is a memory trench. And tell us in the comments, what was the most shocking number for you in this story? The rhythm of Willow Run? The total production? Or the speed with which democracy imposed itself? We read everything. Each comment is fuel for more real history. Don't go away yet. Listen to the next true story that will appear on the screen. Because the Second World War was not only made of battles, it was made of decisions, mistakes, and gears. And in the next video, you'll discover another devastating fact that changed everything without firing a single shot. Always remember, logistics determines strategy. Watch the next video here on the channel with another incredible story.